Can I eat?
All right, so no, you may not.
I'm still hungry.
We just talked about what's happening in the next 2 weeks. Your next quiz is on November 16th, which is not this Thursday, but next Thursday. And today we start operations with functions. So today we're going to look at a couple different things. We're going to add, subtract, multiply, and divide functions. And we're also going to evaluate functions for a value. All right, so on the front of your homework is your note sheet for today. And so let's look at these operations: addition, subtraction, multiplication, and division. And then in addition to that, we're also going to do evaluating the functions. Now, this is awesome because it's exactly as it seems it should be. When I ask you to add function f and g, that just means take f and add g to it. So all we're doing is adding like terms. So in terms of x, what would this look like? Well, f plus g of x would just be, add them up. 5x squared minus 4x plus 5x plus 1. I didn't make the box really well. Hopefully you'll do a better job. It's not going to be big either. Okay, so when I add f plus g, I'm just adding like terms. There's only one squared term. All right, we have a negative 4x and a positive 5x, which makes a positive 1x plus 1. So f plus g is just add them up, add like terms. All right, now we're also going to think about this as time goes on in terms of domain and ranges of the functions. Now, the first function was a quadratic function. So the domain is from negative infinity to positive infinity. The second function was a linear function. So the domain is from negative infinity to positive infinity. They have the same domain. So when we add them together, their domain is still negative infinity to positive infinity. The functions do not limit one another. Okay? So let's look at now how to evaluate this. And there's actually two ways. And it kind of comes from here. To evaluate, and I'm going to show you both ways work. We just found what f plus g is. If you guys need to step out and have a conversation, go right ahead. All right, so we just found this sum. So if we want to evaluate by plugging into that sum, we certainly can. So we would plug in the 3. Okay, and then we just simplify. So 9 times 5 is 45, plus 3, plus 1. 45 plus 4 is 49. Now, because this sum is actually equal to the sum of the individual, we could have done f of 3 and g of 3 and just add those two individual ones together. Whichever one's easiest to you. I think since we just found the sum, the first way is much easier. But let's take a look. I'm going to change colors so you can differentiate between the two. So if we do f of 3, that is 3 squared minus 4 times 3. So this gives us 45 minus 12, which is 33. And then g of 3 is 5 times 3 plus 1, which is 16. And what is 33 plus 16? 49. Now, since we had just found the sum, I definitely like this top method better. It was much easier. But do you see, no matter which method we use, we get the same outcome. Okay, so that's addition. That's all there is to it. Any questions? All right, subtraction. Okay, with subtraction, we just have to be careful to make sure we distribute the negative when we subtract. So if we're subtracting the function, so if I ask you to do f minus g of x, if I ask you to subtract them, what you would write down is f. And in this case, f is 2x squared plus 3x minus 1. And you would subtract g from it. Now when we subtract a function, we have to subtract every term in that function, which really just means in terms of what we're doing algebraically, we have to distribute that negative. Okay? So don't just subtract the first term, subtract them all. Make sure you distribute the negative. And so when we do, we get f minus g is equal to, now we're just going to combine like terms. Here we have 2x squared minus 2x minus 2. And once again, we started with a quadratic and a linear. Different quadratic, same linear. So our domain for both the individual functions and the difference in those is still going to be the same, negative infinity, positive infinity, because that's the domain of a quadratic and it's also the domain of a linear. So now we're asked to evaluate this difference for a given value. So once again, we could plug it in individually and subtract the two, but at this point, since we already have this, this is the way to go. All right, so what we would do is we would take and plug in 2 wherever we had an x and evaluate this difference for a value of 2. So 2 squared is 4. 4 times 2 is 8. And 8 minus 4 minus 2 is 2. Very good. Now just to show you it works, I will go ahead and plug it into each one individually. So here we have 8 plus 6 minus 1 is 13. And then for g of 2, we have 5 times 2 plus 1 is 11. So if I were to subtract these two, do you see I still get 2? So whether you do it individually, evaluate, or you do it after we have done the subtraction, we get the same thing. Now the next one is multiplication. Now this is a small closed dot, just a dot, okay? Because tomorrow we're going to work with composition, which is an open dot. So I want you to be keenly aware, is this dot a closed dot or an open dot? Because if it's a closed dot, that tells me just to multiply, straight out multiplication. All right, so f times g of x. So to find that product, f times g, we would do exactly what you think we should. Isn't this wonderful that everything works exactly like it should?
Yeah.
Yeah. All right, so all we're going to do is distribute here, and then if there were any like terms, we would combine like terms. They're not going to be for this one. So we get the product of f times g of x, is x cubed plus 5x squared minus 3x minus 15. Okay, so if we were to evaluate this product for a given value of -4, since we already have the product, that is the easiest place to plug in. So we would evaluate by plugging the -4 in. -4 cubed plus 5 times -4 squared minus 3 times -4 minus 15. So we do need to keep in mind our rules for powers when we have negative numbers. If we raise a negative number to an odd power, it remains negative. And if we raise a negative number to an even power, it becomes positive. So when we raise that -4 to the third, it is negative 64. But then -4 squared is positive 16. And 16 times 5 is 80, right? And then -3 times -4 is a positive 12. And then we have a negative 15. All right, so negative 64 and positive 80 is positive 16. And 16 plus 12 is 28. And 28 minus 15 is 13. Okay, questions? All right, so let's see if it works if we do it the other way. F of negative 4 is negative 4 squared minus 3, so that is 13. And then G of negative 4 is negative 4 plus 5, which is 1. And what is 13 times 1? 13. This would be f of x times g of x. So whichever method we do, we get the same thing. All right. Any questions about that? Okay. So here comes the one sticker. Every other one, our domains of the initial functions ended up being the domain of our result. The domain of the sum, the domain of the difference, the domain of the product. Now we're doing a quotient. We have division. Now, with a fraction, when we're looking at it algebraically, the denominator can never equal 0. Because if the denominator is 0, then that fraction is undefined. Division by 0 is undefined. So here, when we write it as division, we have to be careful because that denominator can never equal 0. And if it does, we have an undefined function. So with this one, that's what we have to look out for. And so let's take a look at this first one. So if we write it as a quotient, now, many times when we write it as a quotient, we're done. There's nothing else we can do. We have to write it as a quotient, and then we have to do one other step, which is that domain restriction. So that denominator, which in this case is our g of x, that x plus 1, can never equal 0. Can't. Because if it equals 0, then that is undefined. So what we have to do is we have to set up that domain restriction by setting the denominator not equal to 0 in solving. So in this case, we would get that x cannot be negative 1. Because if x were negative 1, it would be undefined at this point. So many times when we do division, we just write the numerator over the denominator and then find that restriction. It's a two-part answer. You must have both parts to get it right. Okay? But in this case, do you see that numerator factors? What does this numerator factor to? X plus 1 times x minus 1.
Can we just leave it how it is and plug in 6?
Okay? Why is that interesting? What do you notice about the numerator and denominator? They have a common factor. X plus 1 is a common factor. And when we have a fraction with a common factor, we can cancel. So in this case, f divided by g of x simplifies to just x minus 1. But we must always write the restriction on the domain. In this domain, x cannot equal 1. So you either write it as a restriction, or if I ask you for the actual domain, it would be everything but negative 1. This is the domain. This is the restriction on the domain. That is the one restricted value. This is the actual domain. The domain is everything but negative 1. Okay, now this is rather unique. And I want to look at this in terms of what its graph looks like because I want you to start thinking about that. Okay? So I'm going to open up Desmos, my favorite graphing utility online. And we're going to see, do you all have a different favorite graphing utility? I heard a little giggle. I even have the app, which I would recommend.
I like Cool Math better.
Do you really? Okay. Okay. Now, did you see how when I just had the numerator, it was a parabola? And then when I added the denominator, it turned into a line. Why do you think that happened? Because what does this simplify to? X minus 1, doesn't it? I'm going to type that over it. Didn't my first function disappear? Yeah, but there's something interesting about this line. What did we say x cannot be?
-1.
-1. Let's see what happens when I come down here to an x value of -1. What does it say?
Undefined.
It's undefined. Whoops, I moved. Undefined. Do you see how it's an open circle right there? So if I were to actually graph this, it would be a straight line that has a hole in it at that undefined value of -1. So this function looks just like this one, but with the blue one, there's no hole. Let's see if I can get it right there. There we go. The blue one has no hole. This one, because of the restricted value, ends up with a hole right here where x is -1. All right? So I want you to just start thinking in terms of that because we're going to look at domains of compositions on Wednesday. All right, so now we're on our way there. So this answer is always a two-parter. I'm good with you writing it like this. The answer to the quotient and the restricted value. If you would rather write out the domain, you can. So this is what it can't be. This is what it is. Do you see the difference? All right. Now let's actually do the evaluation of the quotient at an x value of 6. So all we have to do is plug in 6. All right. So whether we plug in 6 here, here, or here, we're going to get the same thing. Let's prove it. All right, so let's plug it in here first. So if we plugged it into x squared minus 1 over x plus 1. So this is 36 minus 1, which is 35. And 35 divided by 7 is 5. Okay, so that's where we plug it in right here. All right, now let's plug it in here before we canceled. Okay, so we have 6 plus 1 over 6 minus 1 divided by 6 plus 1. Well, these cancel, and we're left with 6 minus 1, which is 5. Or if we plug it in right here, we just have 6 minus 1, which is 5. So it really doesn't matter where we plug it in. So I would pick the easiest one, right? That's where I would pick. I would pick where I already have found the quotient. Now, many times when we write the quotient, it will not simplify. So what if we had if h of x was x squared plus 4 and k of x was x minus 2. Well, you might want to factor x squared plus 4, but a sum of squares doesn't factor. So if I ask you for this, if I ask you to find h over k of x, your answer would be this. There is nothing you can do other than write it as a quotient. And then we have to do the restricted value. What value would make that denominator equal 0? 2. So x can never be 2. So most of the time, they don't simplify. The only time they simplify is when I make them. All right, questions about adding, subtracting, multiplying, or dividing. Okay, now, when you start your worksheet, if it gives you a value, the first thing you do is add, subtract, multiply, or divide, and then you plug in the value. If it just says of x, did you guys notice that that was the first step on every one of them? So if I just ask you for f of g of x, this is all I want. But if I ask you for f divided by g of 2, then you'd have to plug 2 into this. Do you see the difference? So this is just f minus g of x. You'd stop there. This is f minus g of x of 2, and then we'd have to plug in 2. So it depends on what the problem is asking for. For some of them, we're evaluating for a given value, and for others, we are just finding whatever the operation is of x. All right, I would like you to go ahead and begin. Some of you will finish the back of this worksheet, okay? And I'm going to cut off the video, and then I will answer questions.